Hello, Huskies. We're going to talk about writing systems of equations. And yes, I know this is full of a lot of story problems that gives a lot of people anxiety. What I'm going to do is step you through all the classwork, and then I'm going to help you set up the homework, but I'm going to let you solve all the homework problems yourself. So I'll just help you get started. But if you're struggling on how to solve them, you need to go back and listen or watch the video on substitution, because everything we do today can be solved by substitution. Okay, to begin with, we are going to practice translating a little bit. If you treat math like a foreign language, then there's some vocabulary you need to know just so that you can translate from English to math and math back to English. And this is kind of like a little translating exercise. So, first of all, it says 4 less than twice a number is 9. Now, most people are going to start off by writing this 4 subtract something. But now, think about this for a second. If I make $4 less than you do, who makes more money? Well, you do. I make less than that. So you have to start with the total and then subtract 4. And so if we have 4 less than something, it's that something minus 4. Just like think about that, model it through, I have $4 less than you do. Does that mean that I'm going to go 4 minus how much you have? No, it's how much you have minus 4. So 4 less than twice a number. Well, what does it look like when you have twice a number? First of all, what is the number? I don't know. Let's call that X. I don't know what it is. Could be W, could be Y. It could represent anything. Since we don't know the number, we're going to use a variable to represent that. Remember the very first assignment we did this year, we talked about assigning a variable to a quantity. So we don't know what the number is. We're going to call it X. What would twice that number look like? Well, twice something means multiply it by 2. So the coefficient is 2. So twice a number, then I have 4 less than that. So then I subtract 4. And now the word is, or let's see, here's another is, or if it was like a past tense, like was or were, stuff like that, the verb to be usually is where the equal sign goes. So you just kind of watch for that. Is means equals. So twice a number, and then 4 less than that is the same as equals 9. That's all you have to do. You don't have to solve it. You just have to translate it. That's what that means when you translate that into mathematical equations. Okay, let's try the next one. Twice a number again. Let me erase this so we have more room. So twice a number is 2x. It is something, so that's where your equal sign goes. What is it? It's 18 more than 5 times the number. Well, 18 more than something means that I need to add 18 to something. 18 more than, it's whatever it is plus 18 more so that it can be more than. And it is 18 more than 5 times the number. So 5 times whatever the number is going to look like x. Again, don't solve it. Just leave it. Walk away. We're just translating. Okay, number 3, 10 times x. Well, that looks like 10x. Is, there's your variable, your equal sign again, the verb to be, is, was, were, and stuff like that. That's where your equals is going to go usually. So 10 times the number is twice the sum. Twice the sum. So the sum means the answer when you add two things together. So I've got to add two things together. What am I adding together? X and 8. So that represents the sum, x plus 8. And I have to keep that in parentheses to make sure that I'm going to find twice that entire thing. 2 times that whole sum. All right, match the sentence in the first column with the corresponding equation in the second column. This is just matching. So which one of these, A, B, C, D, or E, looks like 3 less than twice a number is 8? All right, well, is 8, that part makes me think it's going to look like equals 8. Oh, well, that's not very helpful. All of these things equal 8. Okay, so then let's focus on the other side. 3 less than twice a number. So, if I have $3 less than $18. Does that mean it's 3 minus 18? No, it doesn't mean that. It means I have $18 and then 3 less than that would be to subtract 3. So that's telling you that the number, twice the number needs to come first, then subtract 3. So what are we looking for? We're looking for twice a number, 2x, and then subtract 3. And that's going to be 8. Oh, look, it's D. All right, how about 3 times the quantity? The quantity is like a grouping thing. The quantity is a group. What is the group? 2 less than x. Remember, all of these equal 8, so we're not even going to read that because they all equal 8. We're just focusing on the other stuff. 3 times the quantity, that means this is going to be in parentheses. This is the quantity. 2 less than x. Well, 2 less than x is x minus 2, and that looks like B. Plus, then you got to go 3 times that. It totally makes sense. 2 less than the product of 3 and x. Product is the fancy math word for multiply. So you're going to multiply 3 times x. That looks like 3x. And then you have to find 2 less than that, so you got to subtract 2. That is A. 2 times the number, which is 3 less than x. 2 times the number, which is 3 less than x. Okay, so I got to go 2 times something. And the thing that I'm multiplying by 2 is 2 times the number, which is 3 less than x. So 3 less than x looks like x minus 3. And that would be the number. And so then this is 2 times it, and that looks like E. All right, 3 times 2 decreased by x. 3 times 2, that sounds like multiplication, yeah. And then I'm going to decrease that by x. And so our last one is C. All right, I hope that helps you translate a little bit. That's going to be kind of useful when we do all these story problems. Okay, so something I'm very, very particular about when I do all the story problems in this entire unit is you have to define your variables. You have to tell me what they stand for, and you have to give me lots of information. You can't just say, A is apples. Okay, what does that mean? Does it mean the price of the apples? How many pounds of the apples? How many apples there are? What color the apples are? Like, you have to be very specific when you define your variables. And I'm not just trying to be a pain in your neck. When you are specific, when you define these variables, that will often help you solve the problem. So for part A, it says, what are your variables and what do they represent? That's when I want you to define your variables. So, Jose watched 6 times as many hours of television over the weekend as Doreen. Together they watched a total of 14 hours of television. How many hours of television did each person watch over the weekend? Okay, if you don't know where to start, often if you just reread the question, it will tell you what you're looking for. And the thing that you're looking for is often the variable. So the question says, how many hours of television did each person watch? Okay, so maybe we could say that X is the number, that's not a hashtag, number of TV hours watched by Jose. And you will find that I frequently don't use the first letter. I don't just say J is for Jose and D is for Doreen. I will almost never do that because then I don't think that gives you an opportunity to think clearly about what your variable represents. So then Y is going to be the number of TV hours by Doreen. So we have 2 people watching TV. We don't know how many hours each one of them watched. So we're going to say X is how much TV Jose watched, and Y is how much TV Doreen watched. Okay. Well, together, they watched a total of 14 hours. So that means that however many hours Jose watched plus however many hours Doreen watched is going to add up to be 14. That's an equation. Let's leave it. Walk away. Okay, but now let's look at this first sentence here. Jose watched 6 times as many hours. Who watched more TV? Again, this is a question that I like to ask myself just so I can make sense of the problem. I just want to know who watched more TV, Jose or Doreen. Well, Jose did. He watched 6 times as much. In other words, however many hours Doreen watched, we called that Y, Jose watched 6 times that much. So X is going to equal 6 times Doreen's. And now, wow, I have written a system of equations. I have 2 equations. I have 2 unknowns, X and Y. And now I can solve them by substitution. So just as a little review, when you do substitution, you're going to say, well, if X is isolated, it's all by itself over here, X equals all this stuff, I'm going to replace X with all that stuff. And that will give me 6Y plus Y equals 14. Now I just have one equation and only one variable. So 6Y plus 1Y is 7Y. And if 7 times something equals 14, and I divide both sides by 7, then I get that Y equals 2. Well, that feels pretty good. Am I done? No. Because the question said, how many hours of television did each person watch? We just figured out Y, which was how many hours Doreen watched. How many hours did Jose watch? Well, he watched 6 times as many. So 6 times 2 is 12. So then Jose must have watched 12 hours and Doreen watched 2. Hey, does it make sense? If we add them up, does it equal 14? Right? Because together they watched 14 hours. Yep, 2 plus 12 is 14. All that work that I show there is what I expect you to show. And maybe even a little more, something like X plus 2 equals 14, so X equals 12. That's how we got that. Or you could have put it into the other equation and said that X equals 6 times 2. Hey, it's also 12. All right, number 10 on the back of your classwork. 2 numbers have a sum of 21. One number is 3 more than the other one. What are the 2 numbers? This is where all that translating practice is going to pay off. So first, define your variables. What do they represent? Well, I'm just going to be pretty simple and say that X and Y are my 2 numbers. I don't know what they are, but I'm going to have them represented by these variables, X and Y. X and Y are my 2 numbers. Okay, let's write an equation. Well, the first thing we know is that 2 numbers have a sum of 21. Sum is the fancy math word for the answer when you add. So that means if I add these 2 numbers together, I'll get 21. Well, an equation for that would be adding them together and equaling 21. Okay, you're done. That sentence right there has been translated into this mathematical sentence right here. So an English sentence and a mathematical sentence, they mean the same thing. So let's look at the second sentence. One number is 3, One number is 3 more than the other number. That doesn't mean the other one like 1. No, it means than the other number. Does it matter which one you're talking about, X or Y? It doesn't really. So let's just call the first number that we're talking about X. And then it must be 3 more than the other number, which was Y. So then X is, what did we say that is means? Usually it's an equal sign. And, oh, I can't read that anymore. Oh, it's 3 more. It's 3 more than the other number, which was Y. It's 3 more than Y. Hey, now we have a system of equations we can solve, and we're going to solve it by substitution. Because X equals all this stuff, we're going to replace X with all that stuff, and we'll get that 3 plus Y, plus the Y that was still there originally, right, equals 21. So 3 plus 2Y equals 21. Let's subtract 3 from both sides. Hey, 2Y equals 18, so Y must equal 9. You're not finished because it says, what are the 2 numbers? Well, I only have one number. One number is 9. How do I find the other number? Let's go back to our 2 equations. We know that they have a sum of 21, so 9, there we go. x plus 9 must equal 21. Or we also learned that x is 3 more than y, which we just found out was 9. And so it must be 12. X must be 12. Does that make sense into this other equation? If this was 12 and we added 9, would we get 21? You betcha, we would. So the two numbers are 9 and 12. All right, here's a football question. This football player, Adam, he made a total of 21 field goals and extra point kicks for a total of 49 points. So he's kicked some amount of field goals and he's kicked some amount of extra points, so like the point after, the touchdown. And all total he scored 49 points by doing that. So the field goals were 3 points and the point after is worth 1. How many field goals did he make and how many extra point kicks did he make? All we know is that together he kicked the ball 21 times successfully. So let's see. We could have x be the number of field goals. We don't know how many times he kicked a field goal, but we do know that all the field goals plus all of the point afters, I'm going to just call this a PAT, that extra point. The number of field goals plus the number of point afters, extra points, was 21. So then one equation is going to be that however many field goals plus however many extra point kicks equals 21. That's how many times he successfully kicked the ball. Let's put another equation in there and put the points on it. So a field goal is worth 3 points. Just think about this. Let's model this a little bit. So if every field goal is worth 3 points and he kicks one field goal, how many points did he earn? 3. If he kicks 2 field goals, how many points did he earn? 6. 3 field goals, how many points did he earn? 3 plus 3 plus 3. Oh, 9. What are we doing here? Well, we are multiplying each of these numbers of field goals by 3. That's how we figure out how many points he scored just in the field goal arena. So he has 3 for every field goal. And how many points are the extra point kicks worth? Just 1. So if he adds up how many points he makes by field goals plus how many points he makes on the extra point kicks, he gets a total of 49 points. That's how many points he has scored for his team. Some were field goals and some were point afters. So here we have this system of equations to solve right here. Just one problem. Nothing is isolated. How do we solve that by substitution? What the heck? I can't do anything right now because nothing is isolated. What if we take this equation, say, and we isolate one of the variables? I don't know which one. Doesn't really matter. You could get the same answer either way. So I'm going to take this x plus y equals 21, and I'm going to isolate the x, I've decided. That means I got to get rid of this y. Remember when we did literal equations and you had to get something by itself, like solve for x, that means get x by itself. So I'm subtracting y from both sides. What? Well, over here, that leaves me with a 0, plus x. And what's 21 minus y? Trick question. It's 21 minus y. So that means that this doesn't matter because that was 0. X equals 21 minus y. What? What are you saying? X equals all this stuff? Let's replace x in this other equation with all the stuff that it equals. That means you'll get 3 times, what does x equal? 21 minus y. Plus this 1y that was already there equals 49. So the only thing that has changed from this equation down to this equation is this x is no longer there. This x has been replaced with everything in those parentheses. Everything else is the same. And then you would distribute your 3 combined like terms, keep solving it. Okay, I'm going to let you finish that one. On your homework, I'm just going to help you set these up. I'm not going to solve them for you. Like I said, I figure the hard part about these is the setting up, and the solving is probably not going to be very hard. If it is, then you need to go relearn how to do substitution. So the sum of two numbers is 36. One number is 2 more than the other. What are the numbers? Well, I don't know. Let's define our variables. X and the Y are going to be the letters I use to represent my numbers. You can use whatever letters you want. A and B, M and N, W and Q. Like, I don't care. But I chose X and Y. Now, the sum of two numbers is 36. That means if I add my two numbers together, I will get 36. It also says that one of the numbers, I don't know which one, let's just say X, is, that's an equal sign, 2 more than the other number. Well, the other number right here is Y. And what does it look like if it's 2 more than that? It's 2 plus Y. So my second equation is that X equals 2 plus Y. And now we can solve this by substitution because I have an isolated variable right here. It equals 2 plus Y. So instead of X, we're going to replace that with 2 plus Y and solve. Okay, number 2. This is based on a true story. When I was in the movie theater looking around at all these people buying popcorn, and I was like, hey, is this smart to buy this refillable tub? I don't know. So this is kind of based on that idea. Ellie likes to eat popcorn when she goes to the movies. They sell popcorn with this large refillable popcorn bucket for $36.50. And then every time you fill it, you have to pay $2.75. Or you can just buy a bucket of popcorn every time you go to the movies and pay $8.50 for each bucket. So clearly, it's a lot of money to invest at first, like $36.50 for popcorn. Plus, that's an empty bucket. After that, you got to keep paying $2.75 if you want popcorn. But after a while, it's got to pay for itself because, oh my goodness, a large bucket of popcorn is $8.50. So how many times would you have to refill this bucket to make it worth the money? You know, you might be waiting in line the next time you're at the movies and wonder this same thing. They have a drink that's a drink special or a popcorn special. How can we figure that out? Well, let's define the variables. Go back to the question. How many times would you have to refill the bucket to make it worth the money? I bet we're looking for an answer to this. How many times to refill the bucket? So I'm going to just say that X is the number of refills, the number of times you pay to fill the bucket, or the number of large popcorns. Let's maybe do it like that. The number of large popcorns, because some of them might be in the refillable and some of them might be in the disposable. But however many times you buy large popcorn, that's what X is going to equal. And then Y is probably going to have to be something with money because we want to know when it's worth the money. So when is it cheaper to buy the disposable program than it is just to buy the refillable program? So we'll say that Y is the cost, total cost for the whole year or for how many times you fill up the bucket. Okay, write the system. Well, we're going to have one equation for each scenario. So let's just do the simplest one first. What would an equation like if you're just paying $8.50 for every bucket of popcorn? Well, that's going to be, the cost is going to equal $8.50 times however many buckets you buy. So if you bought one bucket of popcorn, it would cost $8.50. If you bought 2 buckets of popcorn, it would cost $17, etc. Okay, so then the other situation, how much would it cost if you did the refillable thing? Well, first you got to lay down $36.50. That's just for an empty bucket, an empty plastic bucket. There's no popcorn in it. Well, then you have to pay after that $2.75 times however many buckets you want. So if you just refill at one time, that's $36.50 plus $2.75. If you refill it the second time you go to the movies, that's $36.50 plus $2.75 times 2 because you have refilled it twice. And here we have a substitution system. I know we can solve this by substitution because they're both equal to y. And since they're equal to y, since y equals all that stuff, I can still replace y with all that stuff and solve. Okay, number 3, two angles are supplementary. And I remind you, because everyone seems to forget this, that supplementary angles have a sum of 180 degrees. They add up to 180. So two angles are supplementary. What are my variables? X and Y are angles. Like, I don't know, whatever letters you want to use. I decided to choose X and Y. Those are my variables. Because it does say find the angles. So that's a good hint that that's what I'm looking for. Well, let's write a system. What do we know about these angles? Well, we know they're supplementary. And that means that if I add them together, that's a, add. Oh goodness, I'm making a mess. If I add them together, it will equal 180. So many of you guys couldn't process this concept on the equations test, the first one of the year. If they're supplementary, then you add them together and make it equal to 180. This angle plus that angle equals 180. Okay, what else do we know about them? Well, how about this equation? One angle is 30 more than 2 times the other angle. I wish that said one angle. One of the angles, which one? I don't know, let's say X. One of the angles is 30 degrees more than, what is it more than? 2 times the other angle, which was Y. There you go. Solve by substitution. I'm going to let you finish those. Okay, the perimeter of a rectangle is 876. The length is 1 centimeter less than 3 times the width. Oh, does this stuff just make your eyes roll back into your head? Why are we torturing you like this? Well, we're trying to teach you to think critically and to analyze and be able to create a solution from some words. It's a really great skill. What do we know? Here's a rectangle. The perimeter is 876. So this is like the width, length, width, length. What is perimeter? Well, I'm going to say that W is the width of my rectangle and L is the length of my rectangle. Those are my variables, so that's good. Perimeter. How do I find the perimeter? Well, that's when I add up all the sides. So like if I started here and I just went counterclockwise around the rectangle, it would be like W plus L plus W plus L. I went all around this rectangle, and if I add all those things up, I will get 876. That's what the perimeter is. That's what we just did. Can I simplify this a little bit? Sure. 876 equals 2 times the width plus 2 times the length. That also makes sense because W plus W is 2W, L plus L is 2L. Well, what else do we know? I'm not using this one anymore. So what else do we know about these two variables? How about the second sentence? The length is 1 centimeter less than. I know you're going to be tempted to do this, but that's not right. You have to figure out what it's less than, then subtract 1. It's less than 3 times the width. Well, 3 times the width looks like 3W. And the length is 1 centimeter less than that, so I got to subtract 1 off of it. And that's the length. And then you have a beautiful system of equations to solve by substitution. Okay, 7 people went to the movies. The number of adults is 1 more than the number of children. Well, how many kids were there? I don't know. How many children and how many adults went to the movies? Let's say X is the number of children, because we don't know how many there were. And Y is going to be the number of adults. Oh, how many people total were there? 7. 7 people went to the movies. Some were children and some were adults. That means that however many adults there were, plus however many kids there were, oh, I flipped those around, number of kids plus number of adults is going to equal 7. And the number of adults was 1 more than the number of children. Okay, the number of adults was y, so y is 1 more than the number of children, which was x. So we do have a system of equations, and you can solve it by saying y equals 1 plus x. Then you could replace that y with 1 plus x and keep solving. I'm going to let you finish that. Okay, last one I'm going to set up for you. Jana has 25 coins, but she only has dimes and nickels. She has a total of $1.65. How many dimes and how many nickels does she have? Classic problem. So let's just say then like that x equals the number of dimes. And y is going to equal the number of nickels. Oh, sorry for the yawn. Okay, she has 25 coins. How many of those are dimes? I don't know. How many of them are nickels? I don't know. But if I add them together, I'll get 25. So one of my equations is going to look like, that's messy, x plus y equals 25. Does that make sense? Because the number of dimes plus the number of nickels is going to equal 25. Now she has a total of $1.65. Let's start putting some value on here for the money. How many dimes does she have? I don't know. But we called that x right up here. And so I know then, sorry, that a dime is worth 10 cents. So 0.1 times however many dimes plus, how much is a nickel worth? That's worth 5 cents. And so that's, oh gosh, I'm sorry. So sleepy right now. Okay, so x is the number of dimes. So 0.1 times x plus y is the number of nickels. So it could be 0.05 y equals $1.65. Solve that by substitution and you will have figured it out. Okay, good luck with your homework.